All right, another concept when it comes to solving quadratic equations or algebraic equations of the second order. The we know that we discussed that this is the general form of the quadratic equation, and then from that general form we can create this quadratic formula. Now, there's something special about this formula that even without solving the whole equation, we could know um, the number of solutions that a particular equation would give us. So for example, I can look at x squared plus 2x plus 1, and I should be able to know whether this gives me two solutions or it doesn't give me solutions or it gives me one solution. So how is that important? How is that possible? It's possible because of this radical sign here, okay, this square root. So now, how can we use it to determine the solution? So remember, in our earlier files on algebraic, on real numbers, we said that if you get zero, square root of zero, you get zero, right? If you get a square root of a positive number, you get two numbers. How is that possible? So if I get minus 2 squared, I'll get 4. If I get minus plus 2 squared, I'll get 4, right? So it means that I can find the square root of this number here gives me minus 2. It also gives me positive 2. And that's why we say that a square root of a positive number will be plus or minus that number, okay? And then if we got this same number and looked at uh, the square root of a negative number, right? This will give us, in normal language, we say that this one is undefined, okay? But mathematicians have extended this and they've said that actually this should be able to give you an imaginary number, okay? And it's an imaginary number, this one here, okay? It's square root of 1 that they call imaginary, right? So now if we looked at this, we can already tell that if we have a 0, we are going to cancel out this whole part here. That gives us what we can say that this, we get rid of this, so we have this part remaining and that part remaining. So our solution becomes x is equal to minus b over 2a, like that. So when you have 0, if this gives you 0, then your solution is going to be only one factor or one solution. Then if we have a positive number, we know that we'll get a number here that is going to be plus or minus. Hence, it will impact this number and that number. Then we get what? We get two solutions. But if this is imaginary, it's less than 1, then we have what? We have no real solutions. We don't say we don't have solutions. We say we don't have real solutions. Okay? So this is what happens. So now we can say, we can look at this, okay, and be able to tell. So if this is greater than 0, we said it's positive, so we have two solutions. If this is equal to 0, we said that it cancels out this whole part and gets rid of this plus or minus option, meaning that we just have one solution. So this is going to be one solution. If we have less than 0, okay, this is less than 0, it means that we have a negative here. And that doesn't give us solutions, so we don't have the real solutions. So now let's say we had these three equations. There's this one, that one, and that one. If we had these equations, how would we tell how many solutions each of these had, okay? So let's go through each of these and then work out. So the first one is x squared plus 4x minus 1 is equal to 0. So we look at this format first. Is it in this format that we expect our quadratic equation to be in? Yes, it is. So what do we do now? We figure out what a is. A in this case is 1, because it's supposed to be 1 here. B is equal to 4. C is equal to what? Minus 1. Okay, so now what do? We say that we have b squared, our discriminant, minus 4ac. We try to figure out what the value is here. We can even say d is equal to, but I like to put it like this. So we look at b. B is 4a squared, 4 squared minus 4. Then we have a here. A is 1. We have c. Make use of brackets. So this is c. So here we have 16 minus 4 minus 1. Negatives, don't rush them. Take it easy. So 16 minus plus 4 now, which is 20. Okay. So 20 is greater than 0, meaning that we have what? We have 2 solutions. All right. So D is greater than 0, or 20 is greater than 0. Okay, let's look at the second example. The second example is 4x squared minus 12x plus 9 is equal to 0. Again, we compare with our statement here, okay? And we see that this is already in that format, which is good. And we can say A is equal to what? A is equal to 4, B is equal to minus 12, and C is equal to what? C is equal to 9, right? So we go into our B squared minus 4AC again, right? So this is 12 minus 12 squared minus 4. A we said is 4. C we said is 9, right? So we can simplify this by saying this is 144. And then this one is what? This is 16 times what? Times 9, right? So this is 144 minus, this is going to be 144 as well. The other way to do it is you get a 3 here, you put it there. So that's 16, 16, 16, that's 48. 48 times 3 gives us this one. So it's equal to 0. So we say 0 equal to 0, meaning that here we have one solution based on what we looked at, okay? Because we are saying that D is equal to 0, right? Okay. So let's go to the third one. The third one is a bit complicated because we have a fraction. Normally, fractions are a bit difficult to deal with, so we need to be careful. So is this in our format ax squared plus bx plus c equal to 0? Yes. So we have a is equal to 1 over 3, b is equal to minus 2, c is equal to 4. Now we go and look at our d is equal to b squared minus 4ac, just to make you see how it looks like if you say this. So d is equal to b squared. B squared is minus 2 squared minus 4. 4, we say a is 1 over 3, and c is 4. Okay, so here we have 4 minus, already I can see 4 times 4 is 16 divided by 3. It'll be 16 over 3 here. Now 16 over 4 is 4. 16 over 3 is going to be greater than it's going to be greater than 4, right? Because this will give you something like 12 minus 16 over 3. So you know that D in this case, you don't even need to finish calculating this. You already know that D is going to be less than 0. So you have what? No real solutions. Okay. And there we go. Okay, so this is very important when it comes to determining the solutions that may come from a quadratic equation. Thanks so much for watching, and all the best.